Hey guys, welcome to chapter 2. Just want to throw a special shout out to Tim for helping get me set up for this first shot at this new format. What you are about to see is actually lessons 2.1 and 2.2, largely because 2.1 is effectively just the definition of what a tangent is, and we've been down that road before, and there's not really anything there in terms of problems I want you to do. So, we're going to start off with me drawing a circle. P.S. I'm drawing with my finger, so everything that's usually bad with my handwriting is worse. So, sorry. I'm going to try and draw a tangent line, and that's pretty close. Alright, so we have here a line tangent to the circle. I could find things out about that line. I could find the slope of the line, I could find the equation of the line, and what it's telling me is at that moment, if I was driving in circles in that circle, at that exact moment, it would tell me exactly how fast I was going, at what curve that circle is going. If I was swinging a slingshot over my head, that line could tell me at what force the stone left the slingshot if it heads off in that trajectory. I could have tangents to, oh Lord, that is certainly a secant line, but let's pretend it was a tangent line. If you recall, secant lines cross through twice, and a tangent line would just touch, but since my finger is much wider than my circle, I could not tell. Either way, tangent lines, for reasons that you may or may not remember, become very, very important to us down the road calculus-wise, but practically speaking, a secant line, so let's actually accept that second line I drew, that one, as a secant line. If I were to find the slope of that secant line, I could find the average velocity between the 2 points that it crosses. However, if I found the slope of this tangent line, the first line I drew, I would find the instantaneous velocity at that exact moment. Those are both useful things in practical application, which we're not doing today for certains, because what we're actually doing today has very little to do with tangents and secants. What I'm actually doing today is limits. And we're going to run past all the limit rules really as quickly as possible to get you right to the part where you're working on your limits. So, first things first, a limit as x approaches a. I can feel your judgment of my handwriting, but you write with your finger and make it look good. So, limit as x approaches a of f of x equals L. That's what a limit looks like. Limit, conceptually, if you recall, was that idea of, I think, yes, you're the group that I gave the assignment. So, Bridget wrote the poem about fits, and I don't remember the rest of it, but I have it, and it was lovely. And it was either Tim or Colin had the frisbee that was getting closer to the ground, and I don't remember the other ones. I remember them, but I can't think of them right now, and it's not the most important thing, but you remember yours. Remind me of what they were if you want to. But it gets ever closer and never arrives. So as a graph, it would be like the asymptotes that we see with the tangent or cotangent functions or with exponentials. Those are limits, or they limit the function. If we wanted to evaluate a limit, so for example, the limit as x approaches 0 of something, sure, x plus 1 over x minus 4. In this case, someone's honking their horn. In this case, I'm actually going to just plug in 0, and then it would equal negative 1/4. And I was able to just plug in 0 because it wasn't going to cause my fraction to equal 0 anywhere, and negative 1/4 becomes the limit. It's not that it equals, the equation doesn't equal negative 1/4, but as x goes to 0, that function will head towards, but never reach, negative 1/4. Now I'm going to try something and see if it works. It didn't work. It still didn't work. Now will it work? Be smaller. Yeah. I was trying to leave it up there, but make it little. Cool. Can I write again now? No. Okay, so another example would be, I'm going to still have a limit, thank you very much, computer, as x approaches 0 of the square root of t squared plus 9 minus 3 over t squared. Now this one poses a problem. If I went to plug in 0 here, I would have a 0 in my denominator, and that makes life unhappy. Now this is where I taught you a trick last year about rationalizing your numerator. So what I'm going to do is multiply by t squared plus 9 plus 3, which is the conjugate. T squared plus 9, this is so much easier said than done, plus 3 Why can't I write? Well, sure, now you're moving like I wanted you to last time, but now I want to write. Hold on. Equals. Sure, I have no idea what just happened. So, in my numerator, because it's a conjugate, it's each one squared, t squared minus 9 minus 3 squared, which is 9, over, down here, unfortunately, I have to either distribute or write it out. I'm going to leave it alone because I am old, I have done much math, and I know what's about to happen. Equals, hey, that's a plus. That's why. 9 minus 9 is 0. Sweet. And hey, all that's left up top right now is a t squared, which swing, swing. Be careful. Everything's gone from my numerator, but that does not... I made a no-no. That does not mean my numerator is 0. My numerator is 1, and the no-no that I made is... Come on, eraser. Work with me. Whatever. I forgot to write the limit again. You have to write the limit every time. Limit as x approaches 0. Now, this has got to look real helpful right now, I'm sure. Hopefully you were keeping up because scroll back before it got messy. So, t squared plus 9 plus 3. Now when I plug in 0, can I scroll up now? That's me trying to scroll up. Now when I plug in 0, it makes that go away. I have 1 over the square root of 9 plus 3, and I really need to be able... New page. New page. Add a page. Fantastic. That's what we're doing. Limit as x approaches 0 of 1 over square root of x squared plus 9 plus 3. When this goes to 0, now this equals 1 over the square root of 9 plus 3, which equals 1 over 3 plus 3, which equals 1 over 9. And I have a limit. Sometimes you have to factor and cancel and do other such fun in order to get your limit to be legal. I wonder if I have to do a new page every time, but since this method is working, I'm going to roll with it for now. We also have what are called one-sided limits. So if I wrote the limit as x approaches a, and I put a negative sign after it, that is called from the left. I'm approaching my limit from the left. If I had the limit, whoops, that should be a lowercase l for sure. Cannot ignore. The limit as x approaches a plus of f of x, that is approaching my limit from the right. Which means if I had a graph, here's my graph, sure. I'm going to put an open circle right there, and I probably should have, for the sake of example, Like that. That's a closed circle. You can't tell, but it is. Okay, and we're going to call this 1, and we'll call that 4. So as I approach from the right, I'm closing in on 4. Oh, and we're going to call this A, because I'm approaching A from the right, I'm approaching 4. But as I approach A from the left, I'm approaching 1. Doesn't matter if it's an open circle or a closed circle. It matters what I'm headed towards from whatever direction. Now, if there was no plus or minus, if it was just the limit as x approaches A, just as, okay, in this case, it would not exist because it only exists if I'm approaching the same thing from both the left and the right. Okay, the limit in this case as I approach from the left is 1, from the right is 4. It does not exist when it's approaching from both directions simultaneously. And just for funsies, f of A would equal 4 because that's where my closed circle is. Sorry, I'm looking at what else to tell you. That actually about does it. Limits and logs tend to get really messed up because you get excited because limits have all the rules that you wish logs had. You know, if I have the limit, actually I'm not going to go there right now because we just did logs and you're going to get confused. Just be careful to not apply log rules to limits, and especially not vice versa, because limits are a little bit simpler in terms of their rules. So if you look at the can't write the erasing now, can I? 2.2 exercises. Again, I'm not giving you an assignment out of 2.1. If you can tell me what a tangent and a secant line are, I am a happy camper in terms of 2.1. I think I'm a happy camper in terms of 2.1. Yeah, don't need to do any problems out of there. If you look at 2.2, however, you're going to do you'll see a bunch of graphs. So you're going to be finding limits. Now, limits can be infinite. So if I asked you to find, why don't we just look at number 8 real quick. If I asked you to find the limit as x approaches -3, well, as you approach -3, that guy's heading off into infinity. So that limit is positive infinity. Little freebie there. So here, I would like you guys to do, where's my sticky note that has the, I can't find it. Either way, I'd like you guys to do numbers 5, 6, 7, 8. Let's do 5 through 8 all. And with 8, I don't need you to find the equation of the, actually, yes I do. 5 through 8 all. And let's do 23 and no, maybe just 23. 5 through 8 all and 23. That'll be plenty difficult enough for you there. That is all I have for you for the moment. Tomorrow we will get into the rules of limits and why they have all the rules that you wish log had. And yes, other sidebar. This lesson, obviously, you did not receive in time to view at home. It was actually an accident. I meant to have it yesterday and just didn't work out that way. However, it made me think of something very interesting. Generally, I have had a policy of after a test, I don't give homework that night. But since your homework these days is to view a lesson, that'd be difficult. So I made a decision with this accident, even though you didn't have a test, on days where you have a test. For example, sometime probably late next week or early the following week, you will have a test on chapter 2. after your test that evening, you do not need to view a new lesson. I've decided. You can view that next lesson in the morning when you're in class and have the night off. And I will do a problem set that accommodates that shift in time. It'll be a fewer problems, and you'll get back on track. So if, however, you would like to view it, I will still have them available for you, but I've decided to not make it necessary, at least for this first test. We'll see how it goes, because I like my rule of not giving you homework the night after a test and kind of reward you for your hard efforts mathematically. So, yes, that is my thought. I thought it was a good thought. We'll see how it pans out. There was something else I was going to tell you guys, and I can't really think of it at the moment, so I'm going to let it go, because I can't think of what it was. I really wonder what it was. Oh well, have a lovely rest of your day. Love you bunches of notes, and I look forward to spending all day Friday with you.